Hello students, welcome to my class. Today I am going to discuss from question number 12 onwards. In my previous class I have already discussed up to question number 11. So let's start. The unit vector along I cap plus j cap. Question number 12 is question number 12. Unit vector along this is my axis, this is my x-axis and this is my y-axis. Any vector going in x direction, the direction will be represented by I cap, and any vector is going on y-axis, the direction will be represented as j cap. So here the question is about I cap plus j cap. It means that it is passing through the origin. This vector is I cap plus j cap. And if I want to find out the unit vector along I cap plus j cap, we know that any vector has its magnitude and its direction. Likewise, I can write here I cap plus j cap vector will be equal to magnitude of I cap plus j cap and direction of I cap plus j cap. So this mark is my question, the direction. So if I will find out the direction, I cap plus j cap direction, that will be equal to I cap plus j cap by magnitude of I cap plus j cap. And magnitude I cap plus j cap, its magnitude will be I cap square j cap square plus 2 I cap j cap cos 90 degree. Why cos 90 degree? Because the angle between I cap and j cap, it is 90 degree and square. Then the magnitude will be I cap plus j cap. Magnitude will be magnitude of I cap is 1, as because it is a unit vector. This is 1 square, then 2 into 1 into 1, and cos 90 value is 0, so this whole term will vanish, and I will find out here I cap plus j cap, its magnitude will be of root 2. Then the direction, this term is direction, then the direction term will be what? I cap plus j cap, and magnitude of I cap plus j cap, that is equal to root 2. So my correct option will be I cap plus j cap by root 2, that is option number C will be my correct answer. Option number C will be my correct answer. Next, in interference pattern, the energy is created at the maximum, energy is destroyed at the minimum, and conserved. No, we cannot say energy cannot be created nor be destroyed. It can only transfer from one form to another. This is conservation of energy. And I can only say the energy is conserved. The energy is conserved. Some amount of energy is transferred to maximum and some amount of energy will be reduced at minimum, but we cannot say that it will be created, energy will be created and energy will be destroyed. It will be false option because it violates energy conservation principle. So the correct option will be option number C, that is conserve. Energy is conserved. Next, the shape of wavefront produced by a point source. We know that point source, if this is my point source, let me draw the diagram. So wavefront, this is my point source. This is my point source. If this is my point source, the waves from this source will be like this, and in downward direction it will be like this. These are the waves, these are emitting from my point source, and if I am taking the locus of all points in same phase, like this is a crest, this is a crest, again this is a crest, this is a crest, these are crest. I am taking locus of all point on the crest, it will give rise to a wavefront. It is a wavefront. And as because I am saying this is a point source, the three-dimensional shape of a circle is sphere. So I can say the option will be spherical for a point source. But if the question will be like this, the shape of wavefront produced by a point source at very long distance, it will be planar. As because everyone know this that Earth is spherical in shape, geoid shape in, but as because we are very small in compared to the size of Earth, it seems that as if Earth is flattened, but it is not like that. Earth is spherical. These are spherical wavefront, but at very long distance, the shape will be like this. And if I am observing a small part, this will feel like a plane for me. So at very long distance, a point source will produce planar wavefront. So, but here the question is about shape of wavefront for a point source. For a point source, it will be spherical. Similarly, if I will take the trough, these are the trough. So this is again will be a wavefront. So for a point source, the wavefront will be spherical in nature. Then Rutherford alpha particle experiment showed that the atoms have. So let me explain you what is Rutherford experiment. Rutherford had taken a gold foil, and when he allowed it to incident alpha particle, this is my lead block, in order to prohibit radiation in the backward direction, and here is radioactive material. This is radioactive material. If alpha particle is allowed to incident on gold foil, this is my gold foil. Why gold is taken as the perfect material? Because we know that gold is the highest malleability and ductility property. We can make gold thinner as possible. So Rutherford had taken gold foil as his experimental material. So what he find? He found that maximum alpha particle passes through the gold foil. Maximum alpha particle passes through the gold foil like this, and few are deviated with a high angle like this, and about 1 of 8,000 they return about 180 degree from the incident line. So alpha particle means, alpha particle is what? Alpha particle is helium nucleus. It is only helium nucleus. As because I am saying it's a nucleus, so this will be of positive charge. Then he concluded that as because positive charges are diverted and few of them directly return at 180 degree angle, so he concluded that there must be some positive material. There must be some positive material, and he coined that material as nucleus. So the option will be nucleus. And let me magnify this part. Let me magnify this part. Then the diagram will be like this. This is my atom, and when alpha particle, these are alpha rays, maximum of alpha rays are passing through the atom, as it has a large free space inside it. Maximum of alpha ray passed through the atom, and very few alpha rays got a high angle of deviation. These are deviated with high angle, and about 1 of 8,000 return at 180 degree angle. Return at 180 degree angle. So he concluded that there must be presence of some positive part inside the nucleus, as because alpha particle are positive, and a positive particle will only be repelled with a help of another positive particle. So he concluded that there must be some positive body inside the atom, and that positive body is known as your nucleus. The positive body is known as your nucleus. So the correct option will be option number B. Then another question from atomic physics. The ionization energy of hydrogen atom is 13.6 electron volt. The ionization energy of helium atom would be, what is ionization energy? If we will supply that energy to a neutral atom, to a neutral atom, what happens? The first electron, that is the valence electron, will remove out from the atom and make it ionize. So that energy is known as ionization energy. That we can say the energy required to ionize one neutral atom is known as ionization energy. For hydrogen atom, the energy is 13.6 electron volt. For hydrogen atom, it is 13.6 electron volt. And the ionization energy of a helium atom, we know that the formula for energy, that is equal to minus 13.6 Z square by n square. What is Z? Z is your atomic number, and for helium, helium is 2, 4. For helium at n is equal to 2. That atomic, sorry, Z is equal to what? 2. That is atomic number. And n means the orbit number. Helium has only one orbit, so we can say n is equal to 1. That is minus 1 orbit in ground state. In excited state, the orbit number will change. This Z square means this is 4 by 1, that is equal to minus 54.4 electron. Means the electron will have minus 54 electron volt. That means we can say if we will supply plus 54 electron volt, the resulted energy will be 0, and the electron will free from the free from the atom, or will be free from the nuclear force of helium atom. So we can say the ionization energy is plus 54.4 electron volt. Negative sign indicates that nucleus attracts electron, and that attracted energy is minus 54.4 volt. Means if we will supply plus 54.4 electron volt from outside source, then the resultant energy will be 0, and the electron will free from the nuclear force. So the atom will ionize. So we can say 54.4 electron volt is the ionization energy of helium atom. Then question number 17. The RMS value of current, IRMS, is related to peak value. This is a question from alternating current. We know that root mean square, or IRMS, is equal to what? Peak value by root 2. Peak value by root 2. So the correct option will be IRMS equal to I0 by root 2. Option number D will be our correct answer. 18. If E and B represents the electric and magnetic field vector of the electromagnetic wave, then the direction of propagation of the wave will be along E cross B. We know that the diagram for electromagnetic wave is like this. This is my x-axis, this is y-axis, this is z-axis, this is my electric field vector, and this is my magnetic field vector. All are mutually perpendicular to each other. And E cross B, that is my direction of electromagnetic wave, will be along x-axis and is perpendicular to both y-axis and z-axis. This is my electric field vector, this is my magnetic field vector. So propagation vector will be perpendicular to what? Electric field vector and magnetic field vector, and that is only possible in case of cross product. That E cross B is perpendicular to E vector and B vector as well. So the correct option will be option number D, E cross B. Option number D, E cross B. Next question is, two mirrors are placed at right angles to each other. A man is standing between them, combing his hair. How many images will we see? We know that if mirrors are inclined like this angle is theta. This is mirror M1, and this is mirror M1, and this is mirror M2. Number of images will be 360 by theta. This angle is given as 90 degree. Right angles to each other means 90 degree. That means this will be 360 by 90. The answer will be 4. As because this is an even number, so the number of images will be 4 minus 1, that is equal to 3. There will be formation of 3 images by the 2 mirrors. So the correct option will be option number B. Then last question is, a diamagnetic material in magnetic field moves. Diamagnetic material. So what is a diamagnetic material? Diamagnetic material is that which repels external magnetic field. Like we can say the domain of diamagnetic material like this. These are dipole moment vectors, and if we are supplying external magnetic fields, they will be opposite to each other. Means magnetic dipole moment vector is opposite to H vector, and if this is my diamagnetic material, it will repel external magnetic field. It will repel external magnetic field. So the option will be from stronger to weaker field, as because they are opposite in direction. M vector and H vector are opposite in direction, so they will try to neutralize themselves. So the magnetic field vector will move from stronger region to weaker region, that is only to neutralize the effect of each other. So the correct option will be option number B, from stronger region to weaker part of the electric field. So I have discussed all the questions from question number 12 to 20. So these are the questions, and thank you for watching my video.